good morning. Thank you very much for having me. This is actually a great event for me to speak at because it combines two of my very favorite things in the world, those being tech companies and coffee. So really, really happy to be here. Let me take a quick vote. Microphone or no microphone? Microphone. Perfect. All right. I don't like having things in my hands, but I'll do you that favor. So what I'm going to talk about this morning is a little bit of kind of the past, present, and future of 3D printing. I want to go over the industry as a whole and not focus it exclusively on kind of myself and New Matter, but I am going to weave that story in along the way. So without further ado, let's start with the past. Where did all this come from? 3D printing was actually invented all the way back in 1983, believe it or not. A lot of people are surprised by that. They've heard about it, over the last 5-6 years maybe, didn't realize that this technology has actually been around for quite a while. It was invented by a man by the name of Chuck Hull, who you see here, and his first process was called stereolithography. All right, and the way these machines worked is they would put down a thin layer of a photosensitive resin, so this liquid that's sensitive to ultraviolet light, and then they would shine a laser beam on that light, and anywhere the laser struck, it would turn that liquid into a solid. Okay, so they would scan the laser over this layer of liquid, then they would lower the platform down a little bit into this vat of liquid, and then put another layer of liquid over it, repeat that process layer by layer by layer, repeating one layer at a time, and eventually end up with this nice three-dimensional object. Now, the first part he ever printed was a teacup. All right, why did he print a teacup? I actually have no idea. I was hoping someone would yell out the answer. I don't know why he printed a teacup.
It was a very popular 3D model.
It was very popular 3D model.
An early 3D that you could get any place.
I am so glad you knew the answer to that. Thank you. I guess the Stanford bunny hadn't been invented just yet in 1983. All right, so throughout the late 80s, SLA or stereolithography started to be commercialized, and during the 90s, it became more and more adopted by commercial enterprises. So these are companies using these machines for product development. So say I'm Logitech, and I'm going to make the little remote that I'm holding in my hand. It's expensive to make prototypes of that part, and I want to know whether that remote feels good in my hand before I commit to tooling and injection molding. So rapid prototyping, as it was called back then, or 3D printing, started to be used during the product development process to iterate designs. Okay, we would come up with a design on CAD, print it out, I could evaluate how it feels in my hand. If I want to make some changes, I could refine it, print out another one, go through a few of that, and that way, once I actually start building more expensive parts, building tooling, I knew I had the right shape. All right, so throughout the 90s, that's really what 3D printing was being used for. Around the turn of the century is when I personally got involved with 3D printing. I graduated from Caltech nearby over in 2001 with a mechanical engineering degree, and immediately got a job over at Idealab working for Bill Gross, building robots. Okay, and I built all kinds of robots. There were little robotic floor cleaners for your home. We built hobbyist kit robots that you could program to do stuff like go to the fridge and get me a beer. That was always a very popular application. I built a robot that, it was like a little tank and it had paintball guns on it and it could shoot like 30 rounds a second, and it was the most terrifying thing on earth. And what I realized was that 3D printing was a really great way to prototype all these. So it's not something I had any experience with in college. My education included zero 3D printing, but once I found it, I was completely addicted. Okay, because no longer did I need to send designs out to some machine shop, pay them thousands of dollars and wait 3 weeks for this thing to come back before I could see whether it was right or not. I could actually have a service bureau, okay, these companies that own and operate 3D printers as a service. I could send the part to them digitally, and in a couple of days, for about half the cost of that machine shop, I could get that part back and test it out. So it really accelerated how I was doing things. A couple years later, so now maybe 2003, we actually bought a 3D printer for the office. So now I was no longer using service bureaus, and I actually had one in my facility. And this changed absolutely everything, because now I didn't have to wait a couple of days. I could actually have a physical object in a couple of hours. I could spend the morning on CAD, designing my whatever this part was, click a button, it would start going, and a few hours later, depending on the size of the part, I could have that physical object in my hand. So what happened, it was this really interesting phenomenon with the 3D printer in the office that suddenly, it was like the most popular girl at the dance. Like every engineer was fighting over this 3D printer. We were, getting into the print queue and trying to bump my printer up, or my part up to the top of the list and get yours down below, and fighting over whose job was more important to try to get it done first. It was amazing, and it really solidified in my mind how transformative this technology is going to be, certainly as an engineer, but in the long run, to a much wider market than that. So more on that later. Throughout the 2000s, the technology of 3D printing made some really rapid improvements. So we went from these laser-based resin parts to some new technologies, new materials, new build processes. We had things like selective laser sintering, and what that does is it uses a high-powered laser to melt a powdered plastic, and the key thing here is you can make much more robust parts, like the one you see in the upper left and the lower right. These are made using SLS, or selective laser sintering, and you can make it out of materials like nylons. So it's no longer this fragile, kind of brittle, resin-based material, but it's an actual durable material. It can take temperatures, it can take stresses, it's a real part. Okay, we also saw technologies like inkjet-based 3D printing, and the wild thing there is that you can add pigments to the ink, or to the adhesive that's binding the part together, and make full color 3D prints. So again, just all these new technologies allowing more and more applications. And then what many engineers consider kind of the holy grail was metal 3D printing. So sintering powdered metals into solid objects like aluminums, stainless steels, even titanium. And even more recently, I've heard JPL actually varying the material along the build process. So at one end, you've got stainless steel, and you slowly transform it into titanium at the other end. So really amazing things happening there. So back on my side of the house, while all of these technologies were improving, I was still using that 3D printer that we had bought at the office, this machine that completely transformed what I was doing. But I also started to realize that it was kind of hideous. Okay, this printer was terrible in a lot of ways. It was huge. It was the size of a refrigerator. It cost us like $40,000 or $50,000. We had service technicians maybe every 2 months coming out to fix the thing because it was breaking down all the time. And the materials that we were using, these big cartridges of plastic, right? It's plastic. It shouldn't be that expensive, and yet we were paying like $100 a pound for this stuff. Okay, so there were all these things that were just wrong with it. And we were still inside Idealab, and Bill Gross, if you guys know Bill Gross, this probably won't surprise you, he decided he could do better. So we started a 3D printing company there at Idealab called Desktop Factory. Okay, and our goal was to make a 3D printer that was affordable for small businesses. Okay, this is about 2005, 2006 we're talking now. And the idea was, let's get rid of this $40,000 machine the size of a refrigerator that's a pain in everybody's neck, and replace it with a machine that fits on your desktop. You can sell it for $3,000, $5,000 so that small businesses can afford it. We can sell it to architecture firms, independent product designers, small engineering groups, things like that. So we toiled away working at this thing and got some really nice functional prototypes. We had a few beta customers and never found product market fit. It just never took off. And what we realized at the end of the day was that while the cost was really attractive, the performance just wasn't there yet. Okay, there was a mismatch between what we could do and how much it costs, and we couldn't compete with those service bureaus. Okay, so our customers ultimately would rather pay somebody else to use a really high-end 3D printer rather than own this one on their desktop. So the company wasn't very successful. It ended up being acquired. Nobody got rich. Some people had jobs, some people didn't. It was all right. But really, the end result of all of that is that I had an axe to grind with the 3D printing industry. Because I could see the potential of it at that time, and I could see this trajectory that the industry was on, and imagine that someday this is going to be a huge market, a consumer product, but it was clear that in 2007, that just wasn't the right time. It wasn't there yet. An interesting thing started happening around 2008, 2009, 2010, and that's that hobbyists got really interested in 3D printing. All right, so you know the type. It's guys like me that are sitting at home in their garage tinkering with things. They're building robots, they're building drones, robot best friend, because I don't have one in real life, right? That sort of thing. But these people realized that 3D printing technology was really amazing, number one, that it could do really cool stuff. And they also realized that with the progress technology's made, the increases in computing power, processing power, better software out there, they could actually make one at home. It cost just maybe a couple of $1,000s worth of parts. So it wasn't real cheap, but it was within reach. And a lot of blood, sweat, and tears, a lot of late nights working on software and things to get these things to work right. But you could actually build a 3D printer in your garage. So we saw things like the RepRap project. On the left, you see some RepRaps, if you're familiar with those. We saw MakerBot come into existence. On the right here, you see a Thing-O-Matic, one of the very early MakerBot units. And this was great because it let 3D printing technology get into the hands of a lot of really passionate people who are going to use it. Okay? The thing is, they took a lot of tinkering. These machines typically were not just plug and play and you turn them on and they're going to print for weeks at a time or months at a time without trouble. They were constantly breaking down. It took a lot of fiddling. You had to fine-tune things, make little mechanical adjustments all the time, make software setting adjustments all the time to get these prints to turn out correctly. But once you did that, once all the fiddling was done, you could print some really amazing things like a Yoda Buddha mashup. I mean, why not, right? So crazy stuff people start doing. And the great thing is that you could do this and print this cool little sculptural item in your garage, at home, right, for fun. Now the problem was that because of all the tinkering that was necessary, more often than not, you ended up with something that looks more like this, which we like to refer to as making spaghetti. So it's clearly not a consumer product yet, right? I mean, people are doing this at home, but they're doing it because they're passionate about it and because they don't mind the process of tinkering to get it to work, but that's not a consumer product. Okay, so again, this gets us through kind of like 2010, 2011, so let's go to the present, okay? And by present, I mean really the last 4 years or so. What's happened? Well, because of this hobbyist community making all the progress in 3D printing, suddenly it became visible, and a lot of people realized, hey, this technology is within reach. Okay, this is something that is growing really fast, it's developing really fast, so I'm interested, and not just as a hobbyist, but as a business person. So we've seen a huge number of new companies starting up creating 3D printers. And I mean, there's hundreds of them. I put 4 of them up here for you to take a look at. And I chose these 4 because there's something kind of unique about each one. But there are literally hundreds of them out there. They're all over the place. So just quickly, to give you an idea of the variety that we're seeing, okay? The upper left, this is a Formlabs machine. And it's interesting because it produces very high resolution parts. Okay, and it uses a similar liquid resin process as to what I described before, but it does it at about, I think it's roughly $3,300 or $3,500, something like that. So it's a pretty affordable machine in terms of getting really high resolution 3D prints. On the upper right, this unit I believe is not on the market yet, but they are launching it soon, taking pre-orders and that kind of stuff. But it's from a company called Voxelate, and what they do, they actually simultaneously print plastic material and conductive electronic components, okay, into the same part. So imagine I'm going to use a drone analogy again. Imagine you're making a drone, and you could simultaneously, well, no, you need the structural part, but you also need to connect the batteries to the motors, okay, or maybe the controller to the motor. So with a printer like Voxelate, you could actually simultaneously do all of that. The plastic part to provide the structural integrity, and the conductive elements to connect the controller over to where the motors are. Really interesting stuff. On the lower left is the Zeus by AIO Robotics. That's actually another Southern California company, for what it's worth. And they're taking an interesting approach. So imagine what's happened with inkjet printers at home, right? It used to be a printer, and then it was a color printer, and then it was an all-in-one, right? It's a printer, scanner, fax, copier sort of thing. Well, the Zeus is just that for 3D. So it's got a 3D scanner built into it. You can take an object that you like, put it inside there. It'll use some lasers and cameras, and I don't know how they do it, something cool. Take a 3D scan of the thing, and then you can either duplicate it or you could make some adjustments. Maybe you want to make it twice as big, half as big, whatever it is, and print out a new copy of that thing. So that's pretty interesting all-in-one 3D printer. And on the lower right, you've probably seen this if you're watching the tech news. Carbon 3D has made a lot of waves recently because they've developed a technology that increases the speed of these photosensitive resin printers like the Formlabs unit, but it's faster by a factor of like 50. It's insane. So a part like the one you see it printing here, if that's the size of a tennis ball, traditionally that might take 6 hours to print, 5 to 7 hours, something like that, depending on the printer. They actually printed a part like that on the TED stage in 7 minutes. So pretty wild stuff. So a lot of new printers are coming to the market. A lot of new companies starting up creating printers, but the progress in the industry is not limited to just new hardware. Okay, there are actually completely new business models that are starting to be enabled by 3D printing as well. So I've mentioned service bureaus a couple of times, right? Send a design out and they'll use their fancy 3D printers to send you the physical part or to make it and send you the part back. Well, that model has been kind of brought into the 21st century as well and put online. So companies like Shapeways and iMaterialize, they're now streamlining this and trying to make it accessible to everybody. So if you don't necessarily need a 3D printer or you're not going to use it enough to justify having one at home, you can actually use theirs remotely. All right, so I can upload a design and instantly get a quote back of the price for that object in like 40 different types of material. You know, everything from low resolution plastic to flexible things to ceramics to stainless steel. You can get it gold plated if you want to make jewelry. You mentioned jewelry. So you can instantly get a quote back and find what you want, buy it, and within maybe a few days, a couple of weeks if they're backlogged, you'll actually get that physical object shipped to your home. So those are pretty cool services. In addition, 3D printing has enabled business models around mass customization of physical products. Okay, so traditional manufacturing requires everything to be identical in order to be cost effective, right? If you're going to make a physical product, typically you want to make a mold, and then you want to make a lot of them, and that's how to get the cost down. But 3D printing has brought the cost of customization way down, enabling companies like Unique and Mixi Labs to offer personalized, customized products. Okay, so there's a bunch of other ones out there. I chose these two just as examples. Unique produces prosthetic accessories. Okay, so imagine I've lost a leg and I wear a prosthetic limb, but I want to personalize it and make it my own. You know, maybe I'm a big football fan and I want to get the Denver Broncos logo on my leg and wear that throughout the football season. I can do that through Unique. Okay, and they'll 3D print that device for me and let me accessorize my prosthetic. Mixi Labs has several customizable designs, including these cute little figurines. I've got a Mixi Labs Steve, so I've got it with me. If you want to come around after the talk, I'll show you. It's kind of cute. But you know, it's pretty affordable. I got a completely customized version of myself printed out and sent to me. It was like 25 bucks, right? It's not hundreds of dollars paying an artisan to create this thing by hand. It's pretty affordable now. Finally, in terms of new business models, 3D printing has also enabled independent product designers to suddenly create their objects, their products, in low volume without any upfront manufacturing costs. Okay, so if you go to Etsy.com and search for 3D printed products, you'll find over 10,000 unique items for sale.
Wow.
10,000. And if you just imagine every one of those is, maybe not everyone, the majority of those are made by an independent product designer of some sort, maybe working at home part-time, maybe it's their full-time job. But without 3D printing, there's no way they could offer these items for sale. There's absolutely no way they could put up the upfront manufacturing costs, tool up, deal with the logistics, the packaging, the distribution of a product like that. It just wouldn't happen. And so it's giving an opportunity for a lot of people to make a living sharing their passion with the world, their passion for the design of these products. It just wasn't there before. Really cool stuff. All right, so back on to the story of how I've come into 3D printing. As these business models were developing and some new printers were starting to come onto the market, about 2 years ago, maybe a little more, kind of mid-2013, I started talking to Bill Gross again and said, you know what, yeah, Desktop Factory, that was a few years in the rearview mirror now. Let's talk about that axe to grind that I mentioned. Maybe now's the right time for consumer 3D printing to become reality. Seems like the technology's progressed pretty well. There's a lot of public perception that's improved. Like it used to be, you know, in 2005, I told people I was working on a 3D printer and I would just get the blank stare, right? But in 2013, you talk about 3D printing and people say, oh yeah, I saw something on the news, it was really cool. They made, you know, fill in the blank, a rocket nozzle. You know, they made a prosthetic leg for a dog who was missing one, you know, whatever it is. So the perception had improved enough and the technology had improved enough that we believe that consumer 3D printing could be a reality. So the question in my mind, being an engineer, there's a little bit of conservative engineer left in me. I said, well, is it actually possible? Okay, can we do this cost effectively? It's one thing to say, you know, if you sell a 3D printer for less than 500 bucks, a lot of people are gonna buy it. But if it's costing you $800 to make the thing, that's probably not the most attractive business model. So we got pretty busy. Sorry, Outlook is killing me. Go away. All right, so we got busy building some prototypes. We spent most of 2013 building these pretty crude but functional 3D printers. And the whole goal here was reduce the number of parts in the device. How much can we strip out of a 3D printer? How much can we simplify the mechanics and the electronics and still have a functional printer? And the reason I was doing that is that anytime you're going to manufacture a product in high volume, part count drives costs way up. Okay, the more parts that are in a machine, then that's more parts you have to pay for tooling, it's more parts you have to manufacture, it's more parts you have to ship from where they're made to the assembly plant, it's more parts that some assembly worker has to assemble into the thing, and ultimately, once it's in the hands of the customer, it's more parts that can go wrong and fail, right? So all across the board, the fewer parts you have, the better off you are in terms of cost reduction. So we spent months and months and months trying to simplify these 3D printers, and doing a bunch of cost analysis. And I finally convinced myself and convinced Bill that yes, we could make a 3D printer that's manufacturable at a low enough cost that we can profitably sell it at consumer prices. So that was obviously very exciting, but we realized it wasn't enough, okay? I realized that in researching, digging into the market more and looking at growth, I realized that somebody, somewhere in the world, was going to be the first to sell 1 million 3D printers, because that's never happened. No single company has ever sold 1 million. And I decided that if it wasn't me, I was going to be really, really mad. Okay, so that became the mission of my life. And the switch just flipped and it became, I must be the first to sell 1 million. So how are we going to make that happen? And low cost is really, really important. It's got to be affordable, but it's not enough by itself. What you need for consumer 3D printing is a full ecosystem that makes the thing easy to use. Okay, but an affordable 3D printer that's unreliable and finicky and takes weeks of training to use is probably not a successful product. So what we realized is we need to create an ecosystem around the 3D printer. We need an online marketplace of design. So if people aren't a 3D designer yet, they can find designs to print. Okay, there's a community where people can help them get into it, right? And there's all kind of seamless integration with Wi-Fi connectivity so that they're not tethering their computer with the USB cord and dealing with all the headaches associated with it. In other words, it needs to act like a consumer electronics product acts in the year 2015, right? I mean, let's get real. Like, how many things do you buy that you still have to plug in over USB and don't have a web app associated with it? It's just not how things work anymore. So once we had this concept in mind of the low-cost printer that's easy to use and an online marketplace that's connected, we decided it would be smart to test that theory before committing a lot of time and money to it. So we launched a crowdfunding campaign. This was my first crowdfunding campaign. I don't know, has anybody in the audience done a Kickstarter before? I know Joan has. It's terrifying, okay? It is like absolutely mortifying. So basically you spend months preparing for this thing, and then, so May 28th, 2014, I show up to the office at 4 o'clock in the morning because the campaign's scheduled to go live at 5. And I spend an hour with my teeth chattering and chewing on my fingernails, wondering like, okay, once this thing goes, is anybody actually going to buy it? You know, am I the only one that's drunk the Kool-Aid here thinking this is going to work? So with great trepidation at 4:59 a.m., I hit the go button on the Indiegogo campaign. And sure enough, we saw an article from Wired pop up, and we saw some orders start coming in, and then they started coming in faster and faster, and it exploded, and it was like the most amazing experience of my life. So over a 60-day period, we ended up raising about $680,000 on the crowdfunding campaign, and that's great because it represents 2,500 3D printers that are now on back order. And that's given us proof that people want the product, and it's allowed me to go raise some money and start hiring new employees to really make this whole thing happen. So we started gathering momentum. Again, this was about a year ago. So over the last year, we've started growing the company. At the time of the crowdfunding campaign, we were 3 full-time employees, trying to act like a much bigger group than that. And today, we're about 30. So we've grown by an order of magnitude in just over a year, and spent countless hours getting this technology, or getting the product kind of ironed out, getting all the details done. Lots of trips over to China, get a manufacturing line put together, lots of sample builds, and over this summer, over the last several months, we've done about 3 rounds of prototyping, or not prototyping, but sampling on the assembly line in China, a lot of testing of the product, and at the point we are now, we are on the verge of launching. Okay, we're very, very close, and over the next few weeks, we'll start fulfilling those orders for the Indiegogo campaign, and then by 8-10 weeks from now, something like that, we will be into retail sales and production. So we'll be launching very soon the Mod T. It's $399 retail, which makes it one of the most affordable 3D printers on the market today. It's not the very lowest, but it's one of them. It is certainly, like I said, it's not the cheapest 3D printer around, but within the range of kind of affordable 3D printers, I'm confident that it's the best. It's got a lot of really great user features at a very affordable price. We're very excited for that. So where is it all going? Okay, so I promised you that I would talk a little bit about not just the past and present of 3D printing, but the future as well. And the truth is that nobody knows. Obviously, we're not clairvoyant as much as we wish we were. a lot of people out there think that 3D printing is overhyped. In particular, consumer 3D printing. Exactly what I'm doing. I hear it a lot. You know, it's overhyped. Why do I need a 3D printer at home? What am I going to do with it? All this kind of stuff. I guess my take on it is that there is a lot of hype in 3D printing. There absolutely is. You know, there are a lot of things you read about in the news that are sort of marginally 3D printing, but they put that name on it just because they know it'll get a headline, it'll get people to read it. That makes me nervous. But at the same time, I don't think that that detracts from the value in consumer 3D printing. It doesn't have, you know, the pendulum doesn't have to swing all the way the other direction. So if you ask me for my prediction, 3D printing is going to continue to revolutionize industrial and commercial markets. Manufacturing is going to completely change because of 3D printing, no doubt, and I think most people agree with that. On the consumer side, it is going to find adoption. I am highly confident it's going to find adoption. I think over the next 5 years, 3D printers in the home are going to become very, very common. And over the next 20 years, everybody's going to have them. It's going to be uncommon to not have one, right? And the reason I believe this is that I have seen people gain access to a 3D printer for the first time, and I've seen the satisfaction they get in the process of using it. And an area where a lot of people get confused, I think, when they talk about consumer 3D printing and why do we need it, is they think too much about the end, the final object, and they don't think enough about the process to get there. Right? When I see a 14-year-old kid take something out of his imagination, design it on the computer, and then have that turn into physical reality, and the joy that that brings him, whether or not that finished product is any good or not. It may be a terrible design because a kid made it, right? That happens all the time. It doesn't matter, because the process of creation is very satisfying. We have an innate human need to express our creativity and to make physical goods. I don't think that need is going to go away anytime soon. I don't think that's going to change. So consumer 3D printing is here to stay. It's going to continue to grow. And I would very much look forward to coming back to a Friday morning coffee meetup once we've sold 1 million 3D printers, and I'll give you the update on that. All right. Thank you much. I'd love to take some questions.
Excellent presentation. That was just really interesting, the past, present, and future of 3D printing. And I really like that take-home message of our innate need to express creativity, and I don't think that ever is going to change. And I think that the current trends, and if you're accurate in this, I definitely see 3D printing as empowering a lot of people that don't feel very creative to actually enter that space and start designing just for the pure sake of designing, or actually creating tools or pieces of art that they actually want. So I think that's really cool. It's putting power into the end users. What's going on, Sophia? What's Sonia? Oh yeah, we're definitely gonna do Q&A, absolutely. So I'm just gonna open up the space to Q&A. Please limit it to questions and save comments for offline conversations with Steve. Thank you.
Do you think that there's any use for 3D printing in mass manufacturing to potentially bring manufacturing processes back to the United States?
That's a really good question. It gets a lot of attention in the industry. My personal opinion, and again, this is back to the silly crystal ball photo, right? This is a prediction of mine. I believe that it's going to be very difficult for 3D printing to compete with traditional manufacturing processes, insofar as the goal is to create a large volume of identical products. Okay, it's hard to do something cheaper than injection molding or die casting or stamping, right? However, the improvements in 3D printing are allowing customization at a very affordable price. So any product that benefits from some degree of personalization or customization, in those cases, absolutely, they will be manufactured with 3D printing, and that can be done just as cost effectively in the US as it could overseas.
Hi, my question is about the software, compatible software. Actually, I did 3D software for a while as my job, and it takes massive training and a lot of knowledge to deal with some professional software. But how can you make a very user-friendly software that can go into every single home, as everybody can choose whatever they want to design or whatever they want to print, and make it very easy, accessible, like that kind of thing?
Yeah, this is also a really important issue. You guys are asking good questions. 3D design is challenging. And there's a lot of companies out there that make 3D design software, both for professional and more for consumer use. You know, there are now like free browser-based 3D design software packages out there. But the thing is, making it free and making it browser-based doesn't necessarily make it easy. It still takes a lot of practice and a lot of kind of artistic skill to be able to create these really great objects. So the approach that we're taking at New Matter is to give people a spectrum of options. All right, so for the very beginners, they don't have to do any design with our product. They can go to our online store and find designs that have been done by people who are really skilled, and they can maybe apply a little bit of customization. They can put some text on it, or they can resize it, and then print that out. So they don't have to do any design at all. Okay, and then from there, we're gonna help them through the process of learning some of these free browser-based consumer 3D design type applications. They're getting better and better. We do not write any of that code. So what the approach we're taking is to find partnerships with companies who are making that type of software and figure out which ones are best in class and kind of steer our customers toward them. There are some good ones. I've got kids that are 8, 10, and 12 years old, and all 3 of them do 3D design. Okay, and it took me an afternoon of training. I had to sit with them and walk through all those tutorials with them to get them up to speed, but they can now do it. So it's doable, it's just not super easy. The last area where I like to think, and we spend a lot of time at New Matter, is that there is a ton of 3D design content in the world around us that you can grab without being a designer. Okay, so basically every video game you play nowadays is 3D model based. So why not be able to capture a snapshot of that video game and print it out, right? Minecraft, right? How many people are playing Minecraft these days? They're doing 3D design, they just don't call it that, right? So there's a ton of 3D design happening out there, and there's a ton of 3D data that's printable. We just need to provide people access to it.
Okay. Yeah. The technology looks amazing. 3D printers have always been razors and razor blades. Are you getting into the sale of the materials for printing as well? And will it be throwaway price, or will I have to think before I press print?
Great question. So I mentioned the big industrial 3D printer that I started using early on, and we were paying like $100 a pound for the material. That was frustrating for me. And even as an engineer, that made me think twice about printing an object, right? Because it was expensive, and startup company, you don't have an unlimited budget for that sort of thing. So the approach we've taken at New Matter is that the material it prints with, we call this filament in the industry. It's a spool of plastic, almost like weed whacker line. We sell it in ½ kilogram and 1 kilogram spools for $25 and $40 respectively. So what that comes down to, if you look at, I've got some example objects up here you can take a look at later. For an average size object, it might be $1, $1.50, $2 worth of plastic, something like that. So the approach we're taking is, obviously we need to sell that material at a profit. We are a business, but we're not trying to gouge our customers to the point where they have a disincentive to print. I want my customers using the printer a lot. I want them engaged with it, and jacking the price of the material through the roof would just provide them an incentive to not use it. Over here.
Yeah, what is the range of the ratio of the cost of the software to your equipment that to do something half decent I would be looking at, given the partners that you're identifying to partner with?
So the cost of 3D design software ranges from 0 to nearly infinity. It's all over the place. And there actually are some pretty good, powerful packages that are free. A lot of them, like ZBrush is one that's really interesting for sculpting. And they've got a free version that's incredibly powerful. So I think the full version might be $700, but you can do an awful lot with the free version of it. There's things like Blender, which is an open source package. It's pretty powerful, so it's free as well. But then, if you get to more professional packages, depending on what type of design you're trying to do, you're talking things like AutoCAD or SolidWorks, and that's a few $1,000s for a CPAD.
I have a question. Okay.
Yep. Thank you.
Would there be any advantage in combining holography with the 3D printing and using the holography kind of a prototype that is exactly what you want before you print?
Yeah, I think there certainly could be. And when we start thinking things like holography, augmented reality, virtual reality, all these 3D enabled technologies play together really nicely, right? So just as I mentioned, 3D printing was a great way to prototype before you tool up for a production design. Similarly, digital visualization of some sort, it would be a great way to take a step before even 3D printing. So yes, absolutely. I think these are all kind of a continuous spectrum from digital concept to final physical reality.
There was a lot of talk a year or so ago about the laser sintering patents expiring and low-cost laser sintering. Do you see that as a trend? Will I be able to buy a $400 laser sintering thing that would have much better resolution than your current machine?
Yeah. Also a very good question. I haven't seen anything happening in the market publicly yet. It's hard to say what could be happening privately, of course. Laser sintering is an amazing technology. It will be very challenging, in my opinion, to make that a consumer product for a number of reasons. Even just the fact that you're handling powders is a big problem. I have some experience from Desktop Factory. That was actually a powder-based printing process, and it's extremely messy. It's extremely challenging. You have to worry about inhaling powders. You have to worry about airborne powders causing explosion hazards like the grain silo effect. There's a lot of things with these powders that are kind of scary. And so to put that in a home, I think is going to take a lot of work. It's going to get there eventually, and I think, you know, when I mentioned the 20-year horizon of where 3D printing is going to go, significant technological changes will occur during that time. Okay, it's not going to be, you know, a fused filament fabrication machine for the next 20 years. I don't believe that's the case. Something will change, but I think it's going to have to look significantly different than today's SLS technology.
Do you see 3D printing disrupting manufacturing as design turns into digital IP that's easily distributable in the same way that digital media has been disrupted?
So the way I like to think about this is that it's going to augment manufacturers' business models. And I actually have a lot of conversations with consumer product manufacturers about 3D printing, okay? And there's more than one camp. You know, some of these guys, they look at it as very competitive to what they do because if people can print objects at home, why do they have to buy it from them? I think that's somewhat short-sighted, honestly. I think there are actually whole new opportunities for manufacturers of consumer goods to take advantage of at-home 3D printing. So, you know, the analogy I like to make is imagine that you purchase only what's core about a product, and then you can go home and print the customized pieces, the accessory pieces, the optional pieces, right? So the manufacturer doesn't have to provide you with all of that if you're not going to need it. Or they can provide you with some options that you can choose on your own after the fact, right? So it can actually give them a lot of opportunity for interesting new product lines without needing to invest in the manufacturing of all that stuff up front. You know, it also allows them things like bringing back out of print, so to speak, right? So once products have been discontinued, there might still be a market for those products. It's just not big enough to continue the manufacturing operations, so why not allow it to be 3D printed? Spare parts are the same thing, right? So why have customer support mailing spare parts to somebody if something breaks if they can print it at home? So a lot of these opportunities, I think, are going to start to happen over the next few years. It's going to take time, right? We need adoption of 3D printing in the home to be significant enough that it makes sense for these manufacturers to do these things. But over the next decade, I think we're going to see more and more of that type of behavior.
So although ease of use is needed in the consumer space, you also have a lot of consumers who are impatient. Is your machine faster than others?
Yeah, no, it's not. Just to answer very directly, it is not faster. And this is a common question. It's a common area of misconception or lack of information, I guess. A lot of people who are just learning about 3D printing, they've never heard one way or another how fast or slow it is, so they imagine it like an inkjet printer of, okay, give me 5 seconds and the page pops out, so isn't that kind of how it works? And the answer is no. It takes hundreds of layers to build an object, and each layer maybe takes a couple of minutes, and so you've got several hours to build one of these parts with today's technology. I think over time it's going to become important to speed that up, but I don't see it as a massive impediment to adoption today. And really the reason is that the majority of customers we talk to anyway, once they understand what the process is and how long it's going to take, they just work around it and it's not a big deal. You know, they get into a workflow where they wake up in the morning, they start a print job and go to work or school, and by the time they get home, it's finished. Fine. You know, or they start a print job at night before they go to bed, wake up and it's done. So for most of the people we talk to, it doesn't seem to be a massive issue, but I do believe it's an area that needs to be improved over, again, the next 5 to 10 year period.
Jack Fritz, I'm a patent attorney. Quick question. There's a lot of common elements among the different brands, different versions of these 3D printers. I was wondering how much in your product processes are elements taken from public domain, how much is your own innovation, and how important is patent protection in this market?
That's a super loaded question in 3D printing. so I'll tread lightly. So there's an awful lot that is public domain. A lot about the way most of these consumer 3D printers work, using a thermoplastic that is extruded at an elevated temperature. A lot of that's public domain. In the Mod T, we use essentially that print process, so that, again, public. One of the things that's really unique about the Mod T, and it's actually hard to see in this image, but you saw it in some of those videos I showed, is the 2-axis motion system that moves the build platform around. And it's an innovation that we came up with that, again, to kind of repeat myself, it reduces the number of parts in the printer. So if you just count up how many individual components are necessary to create those 2 axes of motion in the Mod T versus in most other printers, we have about 1/3 as many parts. So it's a big reduction in moving pieces in the thing, and that's part of what allows us to manufacture it so inexpensively. So that, we do have a patent pending on that mechanism. I do think it's important. I personally am a believer in the patent process. I'm not one of the sort of radical open source everything camp. That potentially makes me very unpopular in this industry or in the community because so much of it did come out of the open source movement. And I respect that greatly, but I think the patent process has benefits as well.
Last question.
So one of the reasons why I got into 3D printing is because I was really interested in potentially the ability to cut out a lot of environmental emissions by having local production. So if you look at where pollution comes from, international shipping accounts for like 400 or 500% more than personal automobile use. I was wondering if you've looked into environmental considerations about material, about how does the energy to operate the printers compare to shipping costs otherwise?
That's a good question, and the honest answer is we haven't looked at it a whole lot. Beyond making the choice to use PLA filament, which is a fairly environmentally friendly plastic type to actually print these parts, we haven't done a lot specifically to address that. I do think it's something that's important going forward. I drive an electric car and I've worked for 2 different solar energy companies, so I do believe in environmental consciousness, but it's not something that we've tackled in a really big way yet at Newman.
Great question. Wow. So yeah, just a couple closing statements here. We have Connect Week coming up in the middle of October. We're gonna have some details online very soon. And also, just quick show of hands, if anyone is interested in hiring another person for a specific job, please raise your hand. This is not an opportunity to solicit your services per se, but just an opportunity to connect with someone directly that might fit that description. So please raise your hand, and we'll give you the mic.
We need a Django person today. Anyone know a Django person? What? Django. You don't know what it is? Okay. Cool. Thank you.
Excellent. Anyone else?
Hey, I was up here last week too. Probably not anybody in this room in particular, but I'm looking for entry-level customer service reps. Who anybody knows, anybody who'd be interested, let me know.
Okay.
Okay, this is Tabula. Actually, we're sitting right beside New Matter at Agile Lab, and we're hiring a lot of Java developers, data scientists, algo engineers. So who's interested in doing any of them, let us know.
May I?
Are you following me? Jimmy's got an announcement. I'm going to help him translate. He is looking for he's in 3D printing. He started a company in China. He's now here based in the US. And he is looking for somebody that can help him partner and do some business development. Is that right? So if you have any questions, you can come talk to Jimmy.
Excellent. And
can I jump in with hiring?
Oh yeah, please. Absolutely.
So we've been hiring and we're still hiring. I think three. Shuey, correct me if I'm wrong, but we're looking for an electronics engineer doing embedded systems. We're looking for a content assistant, so somebody to help manage. I mentioned this online design store with all the 3D printable designs, somebody to help coordinate all of that content. And then finally, a supplier quality engineer, someone who's got some experience with manufacturing goods in China and keeping high quality on products.
Okay, great. Thank you again for your amazing presentation, and stick around, guys. Network, do your thing, have some coffee, and then enjoy your weekend. Oh, yeah, the photo bomb. I almost forgot. Thank you. Thank you. Just stand right here. We're just going to take a photo for our archive. And if anyone wants to photo bomb in the back, please help yourself.
I'm sorry. I do both, but